Hey class, today we're going to start section 3, which is all about measurements in science. Measurements do include math, so I'm going to actually split this down into different parts. As an opening, it asks, how old are you? How tall are you? The answers to these questions are measurements, and they're actually a kind of data that we've talked about in section 1. Remember, these are quantitative data. It has to do with numbers. Measurements are important in both science and everyday life, and it would actually be pretty difficult to do science without taking any measurements. If you get to upper level science, even something as basic as biology, when you're learning about the human body or things around us, we are going to use quantitative data or measurements. And what we're going to focus on today in terms of measurements is scientific notation. So our key question in this section is going to be, why is scientific notation useful? Scientists often work with very large numbers or very small numbers. For example, astronomers estimate that there are about 200 trillion stars in our galaxy, and that is a very, very large number that we're working with. And so what scientific notation is useful for is putting that number in a way that we're able to better understand it or express it. And the definition of scientific notation is a way of expressing a value as a product of a number between 1 and 10 and a power of 10. So what that means, there's two parts. Product. Remember, product is multiplication. So that means we're going to have a number between 1 and 10. So let's say 9. We're going to multiply it, product, to a power of 10. So that means we're going to have 10 to some kind of number up here. So let's say 10 to the 9th. Here are other examples we can write it. 3.0, again, notice this number in front is between 1 and 10. And then here, 10 to some kind of power. When we look at this, one thing I want you to know is it says between 1 and 10. So I want to make note that it cannot be 10. It has to be less than 10. Over here, we have 8.6. Again, it's between 1 and 10 times 10. And then here I have my power is to the negative 4. And it's okay that it's to the negative. A couple things that I also want to point out is that this number right here, we sometimes call that the exponent. And that exponent can be positive or negative. So let's look at numbers greater than 1. When we write numbers greater than 1 in scientific notation, we're going to notice that the exponent is positive. So let's say 2 times 10 to the 7th. That is going to be a number that's bigger than 1. Or even 3.8 times 10 to the 9th. Both of those are positive numbers, so they're going to become big numbers. The example the book uses is the speed of light is about 300 million meters per second. In scientific notation, we would actually take this very, very long number here and write it as 3.0 times 10 to the 8th. Times 10 to the 8th. And what they did here is this number, my decimal is at the end. They had to move my decimal over here 1, 2, 3, 4, 5, 6, 7, 8 times. That's where they get this 8 here. And so the exponent 8 tells you that the decimal point is really 8 places to the right of the 3. So if we write, that means if we take this decimal and move it 8 times to the right, it would get us back out to be this 300 million. Well, what about numbers less than 1? For numbers less than 1, the exponent is going to be negative. So down here, I have a number less than 1, 0.00086. And if we were to turn that into scientific notation, we would change it into scientific notation by saying that it is 8.6 times 10 to the negative 4th. So how did we get there? Well, the way we got there is this decimal moved 1, 2, 3, 4 times to the right. 4 times to the right. So in order to undo it, what this scientific notation means, 10 to the negative 4th, is that originally that decimal was 4 places to the left. And if we actually move this decimal 4 places to the left, it gets us back to this number that we have here. So let's actually write down how do we do this. To change from standard form, and when I say standard form, I'm just talking about regular decimal form, into scientific notation, there are 3 things we're going to do. First, we're going to place the decimal point so that there is one non-zero digit to the left of it. When I say non-zero digit, I'm talking about numbers like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Anything other than 0. Once we do that, we are going to count the number of decimal places the decimal point was moved from the original number. And that is going to be the exponent on the 10. So if you move 10 spots, it's going to be 10 to the 10. 7 spots, 10 to the 7th. Then we're going to look at the original number. If it was less than 1, our exponent is going to be negative. If it was greater than 1, our exponent is going to be positive. So let's look at these examples. Right now, if you never see a decimal in the number, it's always assumed to be at the end. So if you don't see a decimal, it is at the end. So here, my decimal is originally at the end over here. And remember, we want to move our decimal where there is only one non-zero digit to the left. So in order to do that, here we have our first non-zero digit. Our decimal needs to move to here. So we're going to rewrite that number with the decimal there, 4.0578. So now we got our decimal moved. Now we have to figure out what our times 10 to whatever power is. So we have to figure out what number is attached up here. So how many times did it have to move over in order to get to the spot? Well, it moved over 1, 2, 3, 4 times to get to that spot. So I'm going to put a 4 up here. Well, then you have to ask yourself, is this number originally bigger than 1 or less than 1? And you're going to say it is bigger than 1, so my exponent up here is a positive 4. Now let's look at example number 2. Now, again, we want to move this decimal that we see right here where there's one non-zero digit to the left. Here, that's a 0, so we don't have a non-zero digit yet, so we need to move it again. Okay, I don't have a non-zero digit, so I need to move it again. Still, these are all zeros, so I'm going to move it one more time. Notice here I have a 3, which is a non-zero digit. It's my first one, so I'm going to stop right there and rewrite that as 3.872. So now I have to figure out my 10 times 10, and I got to figure out my exponent. I had to move it 1, 2, 3 times. So I know there's a 3 up here. Whether that's a positive or negative 3 depends on if this number was bigger or less than 1. Since this number was less than 1, this is actually going to be a negative 3. Let's look at example number 3. Again, I don't see a decimal in here. If you do not see a decimal, it is at the end. So here it's at the end. I only want one non-zero digit to the left. So here, I need to keep moving until there's only one non-zero digit to the left. So I'm going to keep moving. 1, 2, 3, 4, 5, 6. So we know we have the 3. And you can even put 3.0 if it makes you feel better. Times 10, and we said that we moved it 6 times. Because this number was bigger than 1, it's going to be a positive 6. Now you might ask, well, what happened to these zeros up here? These zeros up here are just placeholders, so you can actually get rid of them because they're in front. And these zeros at the end are also placeholders, so you can get rid of them as well. You cannot get rid of zeros that are in the middle though, so keep that in mind. Now let's look at our last example. Here I have a 0 to the left, but I want one non-zero digit to the left. So I'm going to move it, and here I'm going to rewrite it as 4.7826. If you want to put that 0, you can, but you don't have to. Times 10, and I have to figure out how many times I moved it. I moved it 1 time. So then you ask yourself, is the original number over here bigger or less than 1? It is less than 1, So that's going to make that a negative. Oops. Negative. Now we're going to try to do the opposite. We're going to change from scientific notation into standard form, or what we call decimal form. What we're going to do is we're going to simply move the decimal point to the right for a positive exponent of 10. And the reason for that moving right, we want the number to get bigger. Again, positive number, we want it to get bigger. And what we're going to do is we're going to move the decimal to the left if we have a negative exponent. And that's because we want it to get smaller, hence negative, smaller. And then what we're going to do is if we move it and we don't have any numbers there, we're going to use zeros to fill in those places. So here we have 5 examples. First one, we have a negative number. Again, this is negative, which means we want this number here to get smaller. In order for this number to get smaller, we need to move our decimal to the left. So we're going to move it here. We have 1 time, 2, 3, 4, 5. That means my decimal's new spot is right here. So I'm going to put my decimal, and then I have 1, 2, 3, 4 spots that don't have numbers in them. So I'm going to fill in the zeros. 1, 2, 3, 4 spots where there are zeros. Then we're going to write the 4. And then remember, this decimal, we moved it, so it doesn't belong there anymore. And then we're going to write the 7. So 0.00047 is the correct way to write this number in decimal form. Here, let's look at this example. Here we have 10 to the positive 6. Positive means I want this number to get bigger. In order for this number to get bigger, we need to move to the right 6 times. So 1, 2, so we have 9, 8, 7, so we moved it 2 times. 3, 4, 5, 6. Notice I have 1, 2, 3, 4 spots that don't have numbers, so 1, 2, 3, 4 zeros are going to be used to fill that in. Here, let's look at this example. We have a negative 2, which means I need to make this number get smaller, so we're going to move to the left 2 times. 1, 2. Okay, so I have my new decimal spot. I have 1 spot that wasn't filled here, so I'm going to fill that with a 0. And then I have a 1. Remember, this decimal moved, so it's no longer there, so we don't write that decimal. We do have another 1 and a 1 and a 4. So this number, written in standard notation, is 0.01114. Here, we have a positive 1, which means we want this number to get bigger, so we're going to move our decimal once to the right. So this is 28. If you want to write 28 point, that is fine as well, to show that your decimal moved over 1 spot. And last but not least, here we have a positive number, which means we want this to get bigger, so we're going to move to the right. So here we originally had a 6. We're going to move 1 time, 2, 3 times, okay, 4, 5, 6, 7, 8, 9. And we need to fill in these rest of these spots with zeros. So I have 1, 2, 3, 5, 6 zeros to fill in. 1, 2, 3, 4, 5, 6 zeros. So this number written in standard notation is really here. Again, standard notation is helpful because it takes these numbers that are long like this one and puts it in a shorter version that we're all able to understand. Both of these numbers right here are the same exact number, they are just written in a different form. Same thing up here. These 2 numbers right here are the same exact number. They are just expressed and written in a different way. And that's the end of today's lesson. If you have any questions, please make sure you ask. And I hope you guys have a great day.